Okay, I'm going to work sample problem 3 now. If you haven't had an opportunity to try this on your own, go ahead and try that first and see if you can come up with all of the possible solutions, if there are any, first, and then come back and take a look at the answer. So I'm going to go ahead and get started by drawing a figure again to kind of get myself started. You can see here that I've started with drawing the triangle and using the given information to set up my initial part of the law of sines. Now, if you recall in the last sample problem that we had an obtuse angle. We again have an angle that's greater than 90 degrees here. We have angle B that's equal to 100 degrees. Now, the first thing in our process that we should always look to do is just solve for the first triangle. Use law of sines, solve for the first triangle, and if we reference back to our prior table, we see that if the angle that's given, the non-included angle that's given, is greater than 90 degrees, if we're dealing with an obtuse angle, then we only have a couple possibilities. It's either got one full triangle, or there is no particular triangle that fits those measurements, so there's no solution. Now, just a quick glance at the triangle, angle B should be the largest angle, so side B, which is equal to 5, should be the longest side. And based off the given information right now, that looks to be the case. Now, we haven't figured out what side A is, and so we haven't gotten all the way there to verify that, but so far this looks better than it did in the last problem. So we'll go ahead and solve for angle C using this particular ratio and see where it takes us from there. Okay, so you can see here I've done my cross multiplication, and then after cross multiplying my first step, I divided both sides by 5. So I actually kind of skipped a step here just to save a little space. And then to solve for angle C, to get angle C by itself, I had to use the inverse function of sine. And then I punched all that in my calculator and got an approximate value of 36.2 for angle C. Okay, now that being said, finding angle A is really simple. We just subtract the two given angles from 180 degrees. Okay, so now that I have that, now I have an opportunity to get side A now that I have sine A. And again, I'm going to use my completed ratio that I had previously. Okay, so I've set up the law of sines again with my original completed ratio. Now, what I'm going to recommend to you is getting accustomed to doing all of the math and getting the variable that you're looking for to one side by itself. And once you get it to this stage, then at that point, plug all this into your calculator and get one final answer. And so I'm going to get approximately 3.5 as my length for side A. Now, that is going to save you a lot of trouble of having to get intermediate values, rounding intermediate values, and then what happens is the more times you do that within the middle of the problem, your final answer doesn't look the same as what my final answer is here. Now, the only time that I'm going to tell you to possibly do the intermediate values is if you have a problem on Math Excel that would suggest that you do that. But otherwise, it would be beneficial for you to get it all in your calculator and do it all in one calculator operation. So you can see here I've got 3 missing parts, the measure of angle C, the measure of angle A, and side A. Those are the 3 missing parts that we needed to solve the triangle. And we know that since the measure of angle B was greater than 100, or excuse me, greater than 90, it was an obtuse angle, that we only have the possibility of no triangles or one triangle. So there's no need actually looking for a second triangle here.